Hi, and welcome to this presentation, which is a recording of the DevOps Meetup Zurich from the 25th of January 2024. This presentation is all about developer experience and platform engineering. But first, quickly to myself. My name is Romano Ross and I am the Chief of DevOps and a partner at Zühlke. I work for Zühlke now since 22 years. I joined Zühlke directly after university as a junior .NET engineer. Became then an expert software engineer, then an architect, and finally a consultant. And what was always at my heart is how can we continuously deliver value? How can we automate things? And how can we ensure that everything that we are doing has the right quality? And when the whole DevOps movement started, I jumped right on top of that, became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup which we are doing in Zurich. And I'm also one of the organizers of the DevOps Days Zurich, which is a yearly 2-day conference. And the DevOps Days, this is a global movement all around the world, in all of the big cities. There are DevOps Days, and I am the president of the DevOps Days Zurich. And you can see that DevOps lies very close to my heart. And that's also why I have my own YouTube channel where you are watching now this video with over 100 videos all around DevOps. I also post a lot and tweet a lot on my social media channels. And if you want to learn more about DevOps, then don't forget to subscribe to this channel or to one of my social media channels. In my project work, I do quite a lot of DevOps transformation. I'm helping the companies to continuously deliver value. So I work in different industries with different clients. And when I'm there, then I usually see the following picture. The business, together with the clients, they have bright ideas and they put that into Word documents and Jira tickets. And then they throw it over the wall of confusion to the development team. And the development team looks at these Jira tickets and the Word documents. And they say, yeah, if you want to have that button, yeah, we can implement you that button. And they implement something and they throw it over the wall of confusion to the testing team. The testing team looks at that, looks at the specification. It's not the same, but who cares? They test something, it's green, and they throw it over the wall of confusion to the operation team. The operation team says, hey, come on, how should we operate that? That will never work in production. But somehow they manage to get it to work and it goes straight to the client or to the business. And they are like, what is that? We cannot use that. That's not what we wanted. And what you can see there is this blue line. This is the value stream, and the value stream in there is broken by these walls of confusion. And this comes from the silo organization which we have in there. And these silo organization are the business, the development, the testing, and usually these silo organization, they are not working on the same goals, which means they are not aligned. And this usually leads to inflexible and slow processes. There is, of course, a complete lack of alignment. The people are not working on the same goals, not together, even against each other. And working in such an environment is not really fun, so the developer experience is quite low. So, of course, there is a solution for that. DevOps is here to help, because DevOps is a mindset and a culture and a set of technical practices which allows us to organize ourselves across that value stream, so that all of the people are working together on a product, not on a project. on a product because they want to continuously deliver value. The customer is in the center of that product, and we are able to deliver great products with DevOps. Talking about DevOps, we also need to talk about the people. You just saw that we have all the people in there. And of course, with that comes a little bit of confusion because the term DevOps says clearly development and operation. And you can see that in there are more people in there. And so many people out there, many smart people are saying, yeah, we need to fix that term because nowadays security is very, very important. So we need to call it DevSecOps, which is development, security, and operation. And another group of people says, no. Business, they give us the money. We need to call it BizDevOps, which is business development and operation. And you can see that discussion leads nowhere because we need a term like DevSec, Bits, Arc, Comp, QA, Ops, and I'm pretty sure I have forgotten someone. We can also call it just DevOps because DevOps is all about bringing all the people, process, and technology together to continuously deliver value. This is what DevOps in the heart is. Now, science, of course, has looked at DevOps, and there is this awesome book, Accelerate, and I also have a whole video on that book on my YouTube channel, where they have scientifically looked at DevOps and why some of the companies can deliver more value than others. And there is also the State of DevOps report, where they're continuously analyzing every year what the state of DevOps is. And what you can clearly see is, and you see that in these bars, that which shows the high performers versus the low performers. That high performers can, for example, 973 times more deployments into production, which is absolutely awesome. And you see these numbers, and when you boil all that down, then you can see that when you are doing DevOps, then you have a faster time to market, more value for money, higher quality, higher customer satisfaction, and top qualified employees. And in the end, this is what every company wants. So, everything good. Why is not everyone doing DevOps? This is absolutely brilliant. Now, what we see on the internet is these articles coming up, like DevOps is bullshit, DevOps is dead, the new trend is platform engineering, and you can see. So, is DevOps dead? Perhaps we need to have a quick look. What are the challenges when we are doing DevOps? Now, you remember I said DevOps is a mindset, a culture, and a set of technical practices. And I present you, these are the technical practices which you need to implement in order to do DevOps or modern software development across the value stream. Yeah, this is quite a lot. Now it gets even better because our battle cry is you build it, you run it. Let's have a look what that means. For that, you need to have infrastructure like cloud or an on-prem environment. You need to have a runtime like Docker, Kubernetes, or a virtual machine. Then you need to have a continuous integration, a continuous delivery pipeline like GitLab, GitHub, CircleCI, or whatever. You need to have monitoring with Prometheus, Dynatrace, and so on. You need to have security with Snyk, SonarQube, and you need to have more tools like Jira, Confluence. And then, of course, you need to have a cost management because that can be quite expensive, especially in the cloud. And you need to maintain all of these tools. You need to integrate them together and to keep them up to date. And you need to have access and identity. So you need to get access to these tools, and you also need to onboard new people. And oh yeah, I totally forgot. You also want to implement some features with your application. Yeah, that's up there. And you can see that's quite a lot when you build it, you run it. And it gets even worse when we look at bigger companies which have multiple products and multiple value stream. Then you have multiple of these platforms in there. And this usually leads to quite a lot of inconsistencies and redundancies. You can also see that the people lack the operational experience, and there is quite a complexity in all of these tools. So therefore, the cognitive load is too big, and that's why you see all of these articles that DevOps is bullshit. So this is quite bad. The question is, can you scale DevOps? Or should we go back to the silo IT organization where we have a silo for operation? I would say, let's take a quick step back. What does a company want? So when we look at the company, then I have drawn here a picture, and I use here the example of drones because that's something you see and which you can also feel rather than software. But in your mind, you can just think about your software instead of the drone. So here we have a company which builds drones. At the moment, they have a small market share and have small drones, and in the future they want to have a bigger market share and build bigger drones like heavy lifting drones, maintenance drones, and so on. So on the top level we have the board of directors. They have visions exactly like that, getting more market share, and they have a portfolio backlog, a portfolio Kanban, where the big ideas are in, and they are getting the biggest idea, the best idea out of that, which they think this year we can go to the market and get a bigger market share. And in this case, this would be build me a drone which can do heavy lifting. They give that down to the product level. On the product level, you have the product management. And the product manager take this idea down, and they are looking now, what do we need to build a drone which can do heavy lifting? And they create features out of that, like we need to have a bigger battery, we need to have bigger motors, or we need to have a software update. And they give now these features down to the team level. And on the team level, we already have teams working on the smaller version of that drone. And they, of course, are working in an agile way, which means they have POs. The POs take these features, and together with the team, they break these features down into user stories which go on their backlog. So you have a team for the software, you have a team for the battery, and you can also see they already have a continuous integration and a continuous delivery pipeline, which is fully automated, where they are working on that stuff. So this goes in, but you also recognize that we need a new team for that new motor. And for that, we of course need a new continuous delivery pipeline, or a continuous integration, continuous delivery pipeline. And here the platform engineering and the platform team comes into play, because they are delivering a standardized continuous integration, continuous delivery pipeline for that team, so that they can start with no time on delivering value. So this is where this platform engineering comes into play. So of course, the whole drone will get integrated fully automatically, of course, and gets delivered to the customer. So with that, we have more value for money, a faster time to market, better quality, and top qualified employees. But with that, the story does not end, because now we need to continuously monitor these drones and get the feedback back to our teams so that they can continuously improve. But also with that, it does not end, because the feedback needs to go also straight onto the board level, because they now need to know, is the customer satisfied? Are the customers buying this product? Are we increasing our market share? These are very valid telemetry data which needs to go back there. And what you can see in there is that we are doing exactly the 3 ways of DevOps. Continuously delivering fast value to the customer, getting the feedback back, and continuously learning. And these are 3 ways. And what you see here is a so-called digital factory, where you have on the top level the lean portfolio management, which connects the strategy with the execution. Then you have the product management, which organizes the multiple teams which are working on products. You have the product teams which are doing DevOps and continuously deliver value, and they build it and they run it and they own the products. And then you have the platform team which creates the platform, sort of the foundation of this digital factory, so that the teams can do DevOps. Let's have a closer look at that platform engineering. And the most important thing about platform engineering is that you have that platform team which creates your platform, which is an internal product. This internal product contains all the tools which are needed to deliver the products of your company. It has things in there like application runtime, like developer experience, like access and identity, or like observability monitoring, or the whole CI/CD pipeline. So all is in there. What is now very important to understand is the platform team does not operate the products. It enables the teams to operate their own product, which means they have the tools which are needed. They create the dashboards which are needed for these product teams. The product teams, they are based on that platform, creating their own CI/CD pipeline. They also maintain their own CI/CD pipelines. They also maintain their own dashboards, but based on that platform. And this is exactly the magic which is in there. So the platform teams generate value for the teams, and the teams, the product teams, they are generating a value for the customer. And this means that platform engineering enables DevOps in the product teams. So that's what platform engineering is all about. And that's also why platform engineering has emerged in the DevOps space. And of course, Gartner predicts right now that one of the strategic technology trends of 2024 is exactly that, platform engineering. And they are also predicting that more and more industry cloud platforms will come up. Industry cloud platforms is for a specific industry that you have your own platform, which is industry specific. When you look at Gartner, BCG, McKinsey, all of them are very clearly saying that platform engineering is the top trend. What you also can see is that roughly in 2027, they predict that 75% of the organizations will have adopted or will have created their own DevOps platform. So last year, LGT, which is a private bank in Liechtenstein, came to Zürich, and they also wanted to create such a platform, but they didn't want to create it only for themselves. They wanted to go into a co-investment with Zürich to create such a platform and put this platform in an association so that everyone which also wants to have such a platform can also use that platform out of that association. Therefore, we built together with them this platform, which is called Platform Plane, and we put it into the association, which is the Open Platform Plane Association. Now, when we look at that platform, then this platform has different features. At the moment, we have application runtime, which is Kubernetes as a service. We have API gateways, service meshes, all of that in there. Of course, we have an awesome developer experience because developers are one of the main customers of that platform. So therefore, we have a portal, which you will see in the demo. We have also tunneling into the cluster, and of course also automated devsecops, where we automatically find secrets, do license scanning, have automated SAST, which is static application security testing. And what is very important is the access and identity feature, where we can onboard someone in the morning and he or she gets access to all of the tools in that platform immediately. And in the afternoon, we can offboard that person and he or she will immediately lose all of the access to repositories, to tools and everything. Also, centralized security, an important thing, where you can separate the different networks, where you can also enforce policies, and then observability with automated created dashboards, FinOps in there, and at last also the whole GitOps thing, where you have the CI/CD pipelines, the repositories, and all of that. When we look at the high-level architecture picture, and you see all of the people which are working with this platform on top, and you can see all of the tools. We don't abstract the tools away. The people are working with these tools. But beside of that, we have a portal and also a CLI, which they can work on. On the bottom line, you then see that we integrate these tools, and we integrate these tools always over an adapter. This enables us to also replace some of these tools, because you never know what kind of customers are coming with their special tool. So with these adapters, we can easily integrate their special tool. And of course, if one of these tools dies or gets merged with another company, then it's also very easy for us to replace this tool with another tool. So that's quite a good thing, and I also would always recommend you to exactly do that. With that, we are coming to the demo. The first demo will be with screenshots, because we are going into the admin area, and I cannot directly show you the admin area because there is, of course, confidential data in there. When we look at the admin area, then in there, of course, we can onboard new companies. We call these companies partners. So there, when you have such a platform and you will have your own installation of the platform, then you can onboard new partners which you are working with. Which means in that case here you see you could onboard, of course, Zühlke as a partner, and then give one person at Zühlke the right to onboard other peoples. And then this person can onboard more and more peoples, and this is something we do with Bring Your Own Identity. When you have onboarded them, you have the so-called space, and the space is just something like a project, product, or multiple products. You can have everything in such a space. You can even have multiple spaces in there. A space can be one Kubernetes cluster, but it can also be only a namespace in a Kubernetes cluster. This is something you just can configure in there. When we then also look at another screenshot of the admin area, then of course we also track how many users are in there, how many clusters do we have, how many spaces, and what are the costs of the whole platform. This is very important, and also which of these spaces or projects are using most of these or creating most of the costs. And of course, when we look into a space, and here the team has access to that, in a space, a team can onboard their own people, also manage their own people. You can also see, you can create roles like security roles, which then has an impact on what you can change in such a space. And of course, we also show to the team how many costs they are creating. And this is the whole FinOps part of our platform. And with that, let's go into the real demo of the platform plane. So now we are logged into the platform plane. This is the instance which we are using at Zühlke. Of course, if you would have your own instance of platform plane, this would be outside of Zühlke. In this instance of the platform plane, we are doing the projects for our customers which don't have that platform installed. If you, of course, when you are a bigger company, then you want to have your own installation of the platform with your own tools, and then you would exactly get that, and we would integrate your tools into that. So what you just saw in the screenshots are these, this admin area, which I obviously will not go in. Of course, we have a dark mode, which is very important for the developers, but for presentations, we usually use this white or this bright mode. We see the spaces. These are the spaces, the projects where I have access to, and I also see the partners. Of course, I am one of the employees at Zühlke, therefore I see that partner and I can onboard also new people. This is also something you, of course, can limit. When we look at here, then we, of course, have documentation in there. You see here the whole documentation of the platform plane. And of course, you can also switch to an AI assistant, and you can ask that AI assistant how to connect to the cluster. And this is a very interesting thing, because suddenly when you have such a platform, then it gets very easy to do experimentations. You can just add a large language model in there, and you immediately have such a thing like ask your documents, which we have here, which is a simple use case, but you can do that very, very fast. Of course, you can also go through that very classically and just read the documentation, but it's a nice addition to have such an AI assistant. We also have command line tools where you can access this cluster over the command line. You even can tunnel into the cluster, and this is also a very interesting use case where you create a tunnel into the cluster and then work directly on the cluster. This means you don't need to have the whole cluster on your own laptop. It means that you can tunnel into your space of the cluster and then work on the cluster as if your laptop or your development environment is in the cluster. And then you can debug and do all the stuff directly in the cluster, which accelerates more the development speed. As said, you have here the spaces, and of course the platform is developed, the platform plane is developed with the platform plane, and therefore we are going directly in there. As a developer, I immediately see what kind of tools we are using. GitLab in here is used for the repositories and for the CI/CD pipelines. We have a Kubernetes cluster. We use Grafana for the dashboards, Argo CD for the deployment, and HashiCorp Vault for the secret management. Of course, you can plug in whatever tools you want. With these adapters, we are able to plug in whatever you want. At least it needs to have an API, and that's really the magic of that platform. When I click on GitLab, because these tools are integrated into that platform, we of course immediately have access to GitLab. This is of course done by single sign-on, and this is also the magic, because now with that we can onboard someone in the morning and offboard this person in the afternoon, and he or she will immediately lose all the access to repositories, but also to the tools. Now let's head to repositories. I can easily create here, for example, a new repository, which will be in GitLab, but we also have integrations for GitHub. And we see here the repository. I can access the repository by clicking on it. But the interesting thing is here. Now, this repository, and this is the devsecops part of it, is automatically scanned by the platform plane itself. And it immediately shows me what kind of security issues I have in that source code. I even have here credentials. The platform plane itself documents itself. So there is no need to document things like how do I access my repository. It is already done, of course, by the platform. And also, you just saw that we have HashiCorp Vault in there. So the whole secret management is also done by the platform plane itself. And the benefit of having that is, of course, when we know the secrets and we can scan for these secrets in the source code. And when we find a secret in the source code, we can immediately rotate that secret. We have a personal access token and, of course, also deployment tokens when you are creating, for example, your deployment pipeline. Now let's go to the registry. This is the container registry where our images are in there. And you can see here all of the Docker images. You also have here again documentation of how to log in with via CLI. You can even create or push your own images. And when I click on such an image, then I also see all of the tags or the versions of these images. And I also immediately have here again this devsecops built in where these images are scanned, as you can see here, including all of the details. And now what is also interesting, usually, and this is in regulated environment, very, very important, I need to know who has done that problem or who has introduced this security issue. And here I can click on that and I immediately see who has created this security issue with what kind of change. And also, I can also click on that and then I see the pipeline which was executed and caused that security issue down there. We of course also support other package management like NuGet, Maven, NPM and Helm, of course, when you have more classically projects. And then we are going to the platform itself, because below this platform is a Kubernetes cluster. And here we see all of the Kubernetes objects which are in there, or applications which are running in there. And we again can click on such an application, and then we see the application vulnerability, and we would also have here the application violations. At the moment there are no application violations, and you again see here this devsecops. And here you can also see all of the documentation that we are having. And of course you want to add new applications into that, and therefore you can click on add. And there you see now all of the configured applications which you can add. For example, you can add Microsoft SQL Server into that cluster. And Now the magic happens. This Microsoft SQL server will be set up in a fully standardized way, how your company wants to have it, including naming schema, passwords, sizing of it. Everything is of course standardized, and you can configure that completely for your company. And also all of the observability things like dashboards and so on will be automatically created, and it will be automatically integrated into the whole observability stack, which we will see in a minute. Of course, you can also classically just upload one of your containers. With that, you can also, of course, manage the node pools, which is quite an obvious thing where you can just change that. Back to the platform. When I click here on one of the logs, then I immediately are logged into Grafana, and now I see all of the logs of that application. I even have pre-configured dashboards in there. I can click here also on tempo and on service graph and then run query, and then I get immediately this nice graph where I see all of my microservices which I have in our Kubernetes cluster. It is a sort of Dynatrace with open source. Back to our platform. We of course also can create virtual machines if you are in need for virtual machines, so for the more classical projects where you need a virtual machine. And one of the nicest features, quite a new feature, is this one, where usually what you have is you are creating an application and you need to test this application, and then you need to impersonate as a user. And this is a use case which is quite common, and usually you have quite a lot of difficulties to implement that. So we implemented that in this platform because that's of course an easy thing. When you have the whole access and identity under control, then you just can create your own identity and you can impersonate as another user inside of that platform, which is an awesome thing and accelerates massively the development speed for applications. The settings area is something we just saw before when I showed you the screenshots. And of course, we also have here chats. These two chats are hosted in a data center in Switzerland on some Mac Minis. This is just for some clients which don't want to have their data in the internet. So therefore we have these two large language models which are hosted on-prem, and then we have here the classical OpenAI chatbot also in there. So this was, in a nutshell, the platform plane. So what you just saw was one implementation of such a platform, which you will see coming up in the future quite often in all of the companies. And this is what you could see is that with such a platform you can heavily increase the development speed of your product development in your organization. And with that, as you can see, this platform engineering really builds your platform, which is sort of the foundation of your digital factory, and enables your teams to do DevOps. And this is exactly the way how in the future you can continuously deliver value for your customers. And what I always say is, you can see now very clearly that we are entering into the age of industrialization of software development. Thank you very much. And with that, we are at the end of this video. I hoped you will like that video, and if so, give me a thumbs up and don't forget to subscribe to this channel because I will create more awesome content for you.